Let's say we want to do a study about their income. We want to do a study about income. Then I can ask, or I can select a sample from this group, and I can ask them to, from them, their monthly income. Okay. Let's say we collect the data from 20 students about their monthly. Then to get the idea about monthly income, first measure we have to calculate mean or average income. It is very simple. This is the formula. We call X bar. X bar stands for average. Sigma xi divided by n. Then x1 up to xn divided by n. N is the sample size. Then this shows actually some limitations and advantage of the mean. It is the most common measure. Mean is sum of value divided by number of values. That means summation of y divided by number of observations. The one limitation of mean is it is affected by extreme values. It is affected by extreme values or outliers. Now this shows that mean is 13. Now in this data set, we have one observation 11, one 12, one 13, and 14 and 15. Then the mean is 30. Then in the second data set, values are 11, 12, and we have unusual value 20. It is we call outliers. Later, we will learn how to identify outliers. Just think that this is an unusual value. Then due to this unusual value, mean value has increased from 13 to 14. This is a limitation of mean due to outlier value. Mean will increase. If we have an outlier with lower values, let's say one observation we may have with value 2, then the mean value decrease. That also we can identify as a limitation. Then second measure is we call median. Median. In an ordered array, the median is the middle number. It is very simple. You can arrange data set in ascending order. Then the middle value we call mean. The middle value we call mean. It is not affected by extreme value. It is not affected by extreme value. Then median, here 13. Here we have outlier, but there is no any impact of this outlier on median. Then advantage of median compared to the mean is it is not affected by extreme values. Then you should know how to identify median. Okay. Position of median. Then this is the formula. N is the number of observation plus 1 over 2. It's the middle number. Then if the value is odd, median is the middle number. If the value is even, the median is the average of two middle numbers. That means, now we have one example here. Then that means, now let's say uh, we have 5 observations. Then the 5 plus 1 over 2, answer is 3. That means, as in previous, as here, the median value is value in third position. That means we have 5 observations. Okay. Divided by 2 is 3. 3 is not the median position. The third value is the median. Now let's say you have 6 observations. Then the median position is 3.5. Median position is 3.5. Median position is 3.5. Then how can we get the median value? Then let's say you have here one more observation. Then what is the median? Median position is 3.5. It is somewhere here. It is somewhere here. 3.5. Then you can add these two values. 13 plus 14 and divided by 2. It is the median value. Is it clear? Okay, then the third one is mode. Value that occur most often we call mode. It is not affected by extreme value. Used for either numerical or categorical data. There may be no mode, there may be several modes. Most frequent value. Now, let's say in this data set, we have one observation with 1, another observation with value 3, 2 observation with value 5, 3 observation with 9. Then what is the most frequent value? That value occurs most often. It is 9. Okay. It is 9. It is we call mode. Then the advantage is it is not affected by extreme value. You can use mode for either numerical or categorical. This is the only one central tendency measure we can use for both numerical and categorical data. Okay. Then how can we use mode for categorical data? Then again in this class now we have 40 students. If we consider gender as a nominal categorical variable, we have male and female. Male and female. Okay, we can find how many males in this class and how many females. I think majority is female. Then Mode of the gender is female because most frequent category is female. That's why we can use mode for both numerical and categorical variable. In sometime there may be no mode. That means in this case no mode. There may be several modes. Let's say if I put another two observations here, then we have three modes. One is 5, one is 9, one is 12. These are we call central tendency measures, mean, median, and mode. Now this simple example shows how to calculate mean, median, and mode. Quickly see that whether you also can get the same answer, and also you can give an interpretation for these three figures. Who can give an interpretation for these three figures? Any volunteer?
When median and mean
One.
are highly, there's a high difference. The data are highly dispersed data.
Yes. How did you come to that conclusion?
Mm, because the mean is 600,000,
Hmm.
median and mode are small numbers compared to that. So the data is very highly dispersely distributed, I believe.
Okay. But later we will learn how to identify the variation or distribution or disperse of the data set. But still, we learn only three measures: central tendency measures, mean and median. Uh, then any other answer?
So the mean is calculated taking the total value and dividing by the number of uh, items in the group.
Yes.
The median is taken using the equation that is 5 plus
Yes.
1
Yes.
divided by 2.
Yes.
And the mode is the most frequently used number, that is 100,
Yes.
two
Yes.
times.
Yes. Then once we calculate value, then you are right. Then you explain how to calculate or how to identify these figures. But the interpretation is you have to give an interpretation related to the given information. Now these are related to house prices. Then what you can say about house prices? That is the interpretation. What you can say about house prices?
So,
Yes, any other one?
so, when considering the mods, so most houses, number of houses has gone around the price of 100,000, and
Yes.
the consider the whole population, the median, like the middle price, it would be around 300,000.
Hmm.
Uh, So and so average or the mean is 600,000, but it is affected from the maybe a luxury house of 2
Yes,
million. Yeah.
yes. Then actually, this is the way to interpret these figures. Then first you can say about mean value. You can say average price is 600,000, but it is affected by extreme value. Since in our data set, we have one observation with 20 million, sorry, 2 million. Then due to this uh, high value, average has increased. Though average is 6,000, it does not indicate average price. It is affected by extreme value. Then you can say the middle value, median value is 300,000. That means when you consider house prices, 50% of house prices are below 300,000 and 50% of house prices are above 300,000. And also you can say most of houses, the price of most of houses are 100,000. If you have a 300,000, you can buy a middle level house, and 100,000 if you have, you can buy most of houses price are around 100,000. This is the way to give interpretation. Then the mean is generally used unless extreme value exceed. Then in this case, we can't use mean because in the sample we have extreme value. Median is often used since median is not sensitive to extreme value. For example, median home price may be reported for a region. It is less sensitive to outliers. In some situation, we can present both mean and median. This is the way to give a interpretation for the figures. These are we call central tendency measures. Then we have another type of mean. We call it is geometric mean and geometric mean rate of return. Geometric mean rate of return. Now this is the formula to calculate geometric mean. Now let's say you have let's say two observations values. One observation value is 5. The second observation value also 5. Then according to this formula, geometric mean is 5 into 5, 1 over 2. That means 5 to the power of 2 over 1 over 2. Then according to the power rule, you can write down this. Then answer is 5. Then the average of geometric mean is equal to 5. This is the formula for geometric mean. Then we have another concept called geometric mean rate of return. It measures the status of an investment over time. That means to calculate average rate of return over time, the most appropriate measure is geometric mean rate of return. Now this is the formula 1 plus R1. R1 is the rate of return in period 1, period 2 and period n. Okay, then we have one example here for geometric rate of return. Then let's say you have invest 100,000. At the end of year 1, it decreased to 50,000. Then again it has increased to 100. Then the return in the first period is minus 50. Then the next period is 100. Then if you calculate average return, it is 25. Because minus 50 plus 100 divided by 2 is 25%. Then when you compare initial investment and at the end investment, both are same. Both are same. Then there is no any return. But average rate of return says that average return is 25. Is it correct? It is not correct. It is misleading. We don't have average return 25%. Then this is the way to calculate geometric rate of return. 1 plus R1 is rate of return period 1. It is minus 50%. But here we convert it into minus 0.5. That means 50% we have, because we have multiplied it by 100. That's why we use here minus 0.5. 100% means 1. Then when you solve this equation, you can see value is 0. Value is 0. That means the geometric rate of return is 0. Geometric rate of return is 0. It is more representative results, or results shows the real situation. Result shows real situation. Then this summarize the things we discussed up to this point. Arithmetic mean, median, mode, and geometric mean. Then we will, if you have any doubt up to this point, you can raise.
Excuse on the geometric mean, the geometric mean rate of return is like a compounded annual growth rate on investment sort of thing. But that geometric mean, is there like an example of a practical application?
Yes, that means actually for the geometric mean, we use this formula. If values are equal values, okay, if all the values are equal, the geometric mean and arithmetic mean are equal. That means, as I explained, let's say we have two observations, 5 and 5. Mean also, arithmetic mean also 5, but the geometric mean also 5. Then there may be a small difference if you have different values. But rate of return, as you explained, it is very useful. You can apply it to calculate average rate of return for the investment. Okay, then we have measures of variation, range, variance, standard deviation, coefficient of variation. Measures of variation give information on spread, variability, or dispersion of the data set. That means central tendency measures shows the average situation. Measures of variation shows how observations are deviate from average. Whether observations are around the average or whether observations are deviate from the mean value. These are the measures: range, variance, standard deviation, and coefficient of variation. Then the range is a very simple measure. It is different between largest and smallest. It is different between largest and smallest. In this example, minimum value is 1, maximum value is 13, then the range is 12. Then some limitation of range is it ignore which data are distributed. Now, if you consider these two data sets, in the first set, value 7 and value 12. Then the range is 5. Then the value 7 and value 12. But there are 3 observations, 12. That means the distribution is different. But the range is same, 5. Then the another limitation is it is sensitive to outliers. Then here you can see range is 4, but due to this outlier, range has increased to 190. Then the measures of variation, that means the sample variance. Another measure is sample variance. It is the average square of deviation of value from the mean. That means variance shows how each observations are deviate from mean value. This is the mean value. This is the xi, mean each value of x. Then when you take the difference between these two figures, it shows that how each value deviate from the mean. Okay. Then when we calculate variance. Why we take square of it? With the, to get the average value, we divided by n minus 1. And why we get the square of this? Then when you take the difference between mean value and x value, some values are plus. That means some observations are above the mean, some are below mean. Then it is minus. Then when you add plus and minus, it becomes 0. Then if the variance is 0, there's no any mean. That's why we get the square of this. When you get the square of this, then we have value for. Then the sample standard deviation is the most common use of measure of variation. It shows variation about the mean. It is the square root of variance, has the same unit as original data. That means standard deviation is the most common use to identify variation. It shows how data are deviate from the mean. It is related to variance, square root of variance. Why we take square root of variance? To get the same unit as original data. That means, let's say you measure the height in meters. Now you take the difference between average height and mean height, and you get the square of it. Then it's become not the meters, it's become square meters. Then the unit of measure has changed from meter to square meter. Then if you take the square root of this, again it's become meters. That's why it has same unit as original data. Then these are the steps you have to follow to calculate standard deviation. Then this example shows. Please go through this simple example and check whether you can get the same answer. All the steps are given. First, you have to calculate mean value and number of observations. Then please check whether you can get the same answer. I'll give you maybe 5 minutes. Yes, I think you can understand how manually calculate variance and standard deviation. Then the square root of variance is the standard deviation. It is a measure of the average scatter around the mean. Okay. Then one asks in the question in chat box, difference of variance and standard deviation. The difference is actually, if you take variance, as I explained earlier, it change the unit of measure. If it is meter, then when you calculate variance, it's become square meters. Then to overcome that issue or that limitation, we can get the square root of it. Then it is we call standard deviation. Then how can we identify measures, that mean the variation of the data set based on standard deviation? Now see these three examples, please see. Then you can see mean is equal all three data set. First one, observation 11, 12, 13, 16, 2 observation, 17, 1, 18, 1, and 21, 1. Mean is 50. Then the standard deviation here 3.338, here 0.926, here 4.50. What is the interpretation for standard deviation? What you can say about variation of these three data sets? Which data set is more concentrated around the mean? Which one is deviate from the mean? Yes.
Data set B is concentrated around the mean and C is
Yes.
dispersed.
Yes. Then you can see the data set B. Mean is 15.5 and most of observation are around the mean. They are not much deviate from the mean. That's why standard deviation is very low. That means when the standard deviation is low, it indicates that the data are concentrated around the mean. If it is higher value, then it indicates that data are scattered or data are not around the mean. They are deviate from the mean. Then this is 3.38 compared to this one. Some observations are around the mean, but some are deviate from the mean. This is the way to interpret standard deviation. Then this shows graphical presentation. Then later we will learn how we can derive this type of curve. This is we call data set 1, small standard deviation, large standard deviation.
Excuse me, sir. The standard deviation is used for comparison between different data sets, is it?
Yes, if you want to make a comparison between two data set, one measure you can use is the standard deviation. Then we have another measure we call coefficient of variation. That is the most suitable measure for the comparison. In
Right.
next, I think next few slides we will discuss this one.
So for an individual data set, can we interpret the standard deviation, for example, in your previous data set, it is about 4.5% or
Yes.
4.5. So
Yes.
can we say that if the mean is 15.5,
Mm.
then the standard, on average, the deviation is 4.5%.
Yes.
Is that correct? If we
Yes.
interpret it.
That means now if the value standard deviation is high, it indicates that data deviate from mean. Then the standard deviation shows actually average deviation from mean. Then here mean is 15.5. Okay, mean is 15.5. Then the on average data deviate from mean by 4.57. That means they are not around the mean. But in the data set B, mean is 15.5. The average deviation from the mean is 0.926. That means you can see here mean is 15.5. Lowest value is 40. Maximum value is 70. Then most of data are 15 and 16. That's why average deviation is 0.926. Then for individual data set, also you can make a, you can interpret if standard deviation is very high compared to the mean, then data deviate from mean. If it is a small value, data are concentrate around the mean.
Uh,
Yes.
Sir, is there a reason why when you're taking the standard deviation, it is divided by n minus 1 and not n?
Uh, no, actually there's no any special reason. Mm, then we want to see the average figure. That's why we divided n minus 1. That is the common rule we are using. But I don't think that there are any special reason for that. Okay, then we have another measure called coefficient of variation. This is very useful measure to make a comparison between two or more than two data set. Measure relative variation always in percentage, shows variation relative to mean, and can be used to compare the variability of two or more set of data measured in different units. That means if you want to make a comparison between two data sets which are measured in different units, let's say one data set is measured in meters, the other one is measured in centimeters. Then if you want to make a comparison between these two, if you use standard deviation, then your conclusion may not correct. Because one is measured in meters, meters mean small value, the other one is measured in centimeters. Then better to use coefficient of variation. Then see this example. We have stock A and stock B. Average price last year, let's say 50, standard deviation 1. Then the coefficient of variation is standard deviation as a percentage of average value. Then here both stock have same standard deviation. Okay. But stock B is less variable relative to its price. Here price is 100, here price is 50. If you only consider standard deviation, your conclusion may be, you can say both have same standard deviation and both are equally distributed, or they are equally scattered around the mean. But mean is different. Then relative to mean, stock B is less variable relative to its price. Then another example, let's say stock C, average is 8, standard deviation is 2. Then if you make a conclusion based on standard deviation, stock C is less variable compared to the stock A because standard deviation is 2. But stock C has much smaller standard deviation but much higher coefficient of variation. If you take the standard deviation as a percentage of average, it is 25. Then which one is more volatile or more dispersed? This is relative to mean. This is 10%. This is 25%. This is the way to interpret measures of variation. Then we will move to next concept, Z-score. Actually, this is not a descriptive measure. Z-score you can use to identify outliers. Z-score you can use to identify outliers. To compute the Z-score of a data value, we subtract mean and divide by standard deviation. This is the formula for Z-score. X minus X bar divided by standard deviation. X represent data value. Then how can we identify outliers based on Z-score? The definition of Z-score is the number of standard deviation the data value is from the mean. If the Z-score is 3, it indicates that the data value is deviate from the mean by 3 standard deviation. Let's say as example, mean is 50. Standard deviation is 10. Then if the Z value is plus 3, it says that the particular value is 80. Mean it is about 3 standard deviation from the mean. Mean is 50. About 3 standard deviation mean standard deviation is 10. 3 standard deviation mean 30. It is 8. If the Z score is minus 3, what is the value of X? Value of X become 20. Then standard deviation shows how many Z score shows how many standard deviation the data value deviate from the mean. Then this is the formula or this is the criteria you can use to identify outliers. If the Z score is less than minus 3 or greater than 3, you consider these are outliers. Less than 3 and greater than 3. If it is 3.1, that means that particular value is above 3.1 standard deviation. Then see this example. Please see this example. Then mean value is 190. Standard deviation is 100. Particular value is 602. Then the Z value is 1.3. 1.3. That means 620 is 1.3 standard deviation above the mean. And we would not be considered an outlier. It is not an outlier. Then let's say another value. Let's say if you take value 800, do you think that this is an outlier? The value 800, is it an outlier or not? Please try to understand or please calculate and send your answer into chat box. The question is, mean is 800, 490, standard deviation is 100. Then the one observation we have 800. Then whether this is an outlier or not. Please send your answer with the reason to the chat box. I'll give maybe 2-3 minutes. Please send your answer into chat box.
Yeah.